This is going to be my one and only quick review of dimensional analysis. If you were doing the homework and you struggle with dimensional analysis, now's your time to work on it. There's a video online for you already on Schoology. I'm also robotics. After next Monday I'm done with it, so I'm gonna be here all this week, other than Wednesday. Stay after school, and we can do dimensional analysis of questions until we're both blue in the face and the buses come to take us home. I have no problem doing that. But the thing is that I'm expecting that you already know how to do this, and you already know how to do it fairly consistently. I do outline the steps here to give you a helping hand. Write down your equality or qualities, depending on how many units you need to transfer over to. Copy down the units that you're given. Multiply the numbers by the equalities written as a fraction. We'll walk through them together. Multiply through the problem and write your answer with the correct number of sig figs. So if I'm looking at question number 1, I need to go from inches, 575 inches, to yards. Now, I don't know that number off the top of my head, but thankfully, my question writes that out for me. Isabel, if you don't have the sheet, it's next to the bins up front there. I have some extra copies. I know just by looking here, 1 yard. 1 yard equals 36 inches. So in dimensional analysis, all I'm doing is I'm changing how I read the number. I'm not changing the number, I'm just changing how I read it. I want inches to yards. How am I going to do that? I'm going to use those equality fractions that we saw all the way back in September. So first thing I need to do is I need to rewrite my question. I have 575 inches. I need to convert that to yards. Now, I'm going to say a lot of stuff like numerator, denominator. Now, if I have a whole number and I want to turn this into a fraction, it's very easy. All you got to do is put it over 1. Any whole number over 1 becomes an instant fraction, and it's going to make it easier. There's my numerator. There's my denominator. Now, when I'm doing my dimensional analysis, when I use my equalities, I want my units to cancel each other out until I get my desired unit of yards. What's in the numerator first has to be in the denominator, my lord, here comes my stutter, of the next fraction. So I take my equality, 1 yard equals 36 inches. 36 inches equals 1 yard. Now, if I have to run that out completely, I would have 575 inches times 1 yard. Because remember, we're multiplying our fractions. The numerators get multiplied together. My denominators get multiplied together, right? 1 times 36 inches. If it's in my numerator and my denominator, they cancel each other out. So my symbol for inches cancel each other out. I can also cancel out the 1 if I really want to. So that leaves 575 divided by 36 yards. 575 divided by 36. That's my yard. If I pull up my handy dandy calculator, 575 divided by 36 gives me a total of 15.972 repeating into infinity. How many sig figs am I going to use? My numerator had 3. My denominator had 2. How many sig figs? Oh, sorry. Because I'm starting off with... Sorry. I'm getting my rules mixed up in my own head. Because I started off with 3 sig figs, my final answer has to be in 3 sig figs. So that would put it... Is that going to be 15.9 or 16.0? If my answer is 15.972 repeating, am I looking at this writing at 15.9 Or am I going to record that at 16.0? 16.0. 16.0 yards. Now my next one, I'm going from inches to miles. Now, I could sit there and memorize all these different conversion factors, but there's only 5 conversion factors I've required you to memorize, and they were on the metric system. If I'm doing inches and miles, that's the imperial system, the one that we use here in the States. Honestly, the least effective one. So 5400 inches. Now I see that I have 12 inches equal 1 foot. And I have 5,280 feet equal 1 mile. So I start off with a whole number. I'm putting everything into fractions. You know what I'm going to do? Put that into a fraction too. Easy peasy, lemon squeezy. I never have to guess if I'm doing it right if I just throw it into a fraction. Which one do you think I'm going to use first? Am I going to use the inches to feet or the feet to miles to get rid of my inches? Inches to feet. 12 inches equals 1 foot. I want miles though. Means I got to do one more, right? 5,280 feet equal 1 mile. What's going to be in my denominator? The feet or mile? Not mile. The feet. 5,280 feet equal 1 mile. Because remember, I want these units to cancel each other out. Because if I stretch this out, 5,400 inches times 1 foot times 1 mile divided by 1 times 12 inches times 5,280 foot. My inches cancel each other out. My feet cancel each other out. And my ones cancel each other out. That's going to leave me 5,400 divided by 12 times 5,280 miles. Take my handy dandy calculator. I do 5,400 divided by parentheses, because make it easier. 12 times 5,280. I close my parentheses. How many sig figs do I have? 2 or 4?
2.
2. Remember? My tailing zeros don't count unless there's a decimal place, right? So I only have 2 sig figs. So I'm going to take my final answer here. Does this 0 count as a sig fig? It does. Because there's a decimal place. So am I going to round it to 0.85 or 0.9? Well, 0.09. Yeah. 0.09 miles is my correct answer on this one. I know it's something we haven't seen in a while, but it's a fairly straightforward process. We keep working on it. 1250 centigrams. I need to get the kilograms. Now, I don't have... Oh, sorry. I'll read number 4. Number 3. Let's go to number 3 first. Number 3. 4,000 liters to milliliters. Now I know that there's 1,000 milliliters in 1 liter. So I've rewritten my problem. 4,000 liters. I always like writing out my equalities because it's just in my handwriting so I can see it. Also, it's one of the rules. You're supposed to rewrite your equality or equalities that you're going to use. Most of the ones that you guys are going to use in this class are going to be either 1-step or 2-step equations. You won't see too many things where we're going to go like super far, at least right now. Now, I have liters up top. What should be on the bottom of my next fraction? Should I have the milliliters or liters on the bottom? Liters. 1 liter equals 1,000 milliliters. So I rewrite that question. 1,000 liters times 1. Oh, sorry. 1,000 milliliters. 1 times 1 liter. My liters cancel each other out. I have no ones up top, so I can't cancel them. So I pull out my handy dandy calculator again. 4,000 times 1,000 gives me a total of 4. 1, 2, 3, 4, 5, 6. I don't feel like writing out all those zeros. Is there a way I could just abbreviate that with scientific notation? How would I do that? Or I can just multiply it by 10, right? By a factor. I hear you. Give me a second. If I don't want to write out the zeros, I can just move the decimal place over. 1, 2, 3, 4, 5, 6. 4 times 10 to the power of 6 milliliters instead of writing out 4 followed by 6 zeros. I make it easier. I don't want to write all that. I don't want to write big numbers. That gets annoying after a while. You got a pass from me, Kelsey? You got the homework? Get it up. So, looking at the time, I'll speed up a little bit so I can make sure we get through enough of the coursework that we're going to do. 1250 centigrams to kilograms over 1. I have my two equalities. I have centigrams up top. I want centigrams on the bottom. So 1 gram times. I'm looking at my next one. I want grams on the bottom for the next one. 1,000 grams equals 1 kilogram. Centigrams cancel, grams cancel, so everything's just going to be in kilograms. 1250 divided by 100 times 1,000. I have 1, 2, 3 significant figures. So that means my final answer also has to be in 1, 2, 3 significant figures. Now, interesting that we see the mole here. The mole is what we're going to be getting into this unit. It is a fairly quick unit, so just keep that in mind. But it's kind of like saying I want a dozen of eggs. We're going to see that the mole just equals a certain amount of atoms. That's what our takeaway is going to be today, and how we can figure out what the mole is of an element. The next time I see you, today's Tuesday, on Thursday, we're going to be able to calculate the moles of our formulas. But first steps first, we'll talk about in a second. So I got 54.5 liters. I need to convert that into moles. I got this nice little awesome quality right here. 1 mole equals 22.4 liters. Rewrite my problem. 54.5 liters. Put that over a fraction. I still have liters on the top. So my liters got to be on the bottom. Next one, 22.4 liters equals 1 mole. So that's going to be 54.5 divided by 22.4. Gives me a crazy number. It goes on forever. But I start off with 3 sig figs. I'm going to end with 3 sig figs. 1, 2, 3, 2.43 moles of whatever I'm working with. Oh, not moles, mole. And lastly, looking at number 6, I have 54.5 liters liters of something, and I need to convert that to molecules of nitrogen monoxide. So I'm given the same quality from before. 1 mole equals 22.4 liters. I'm also given the equality that we're going to see today a lot. 1 mole equals 6.02 times 10 to the 23 molecules. So I will start off by Rewriting my problem, 4.5 liters. Put down a fraction. I start off with liters up top. I got to have liters on the bottom. 2.4 liters equals 1 mole. Now, I see 1 mole equals 6.022 times 10 to the 23rd molecules. So, if I was to stretch this out, I would see that my moles cancel out, my liters cancel out, leaving everything going to be in molecules. Now, I could type in 2.022 times 10 caret 23, but if I'm also multiplying that 54.5, if I don't put it right, if I don't use parentheses around the mole, I'm going to make a mistake. So, what I do, I hear you, give me a second, 54.5 times, this is where we're using that E function, right? 6.022 shift, make sure you hit the shift, you see a little up button, and you're looking for the double E. Click on this button right here. So you're going to see 6.022 E23. Remember, the E, pull this down, the E represents times 10 to whatever number you type there. It's a function that we use on our calculator. It does a lot of the work for us. We don't have to fight it. Make sure you're hitting that Shift EE button, which is the little apostrophe symbol here. But I'm not done. I have to divide this by 2.4. And I have my final answer. I start off with 3.66. My final answer has to be 3.6. 1, 2, 3. So 1.47 times 10 to the 24 molecules of, nitrogen dioxide. Like before, I want to see those fractions. I got to see them. A lot of us, we just kind of broke it down, and you kind of gave me the end bits. It's great, you got to the answer, but I can't see the work that got you there. You got to show me that work. How are you going to do that? By your dimensional analysis equality fractions. All right. So, it's very funny that we just talked about the mole because now we're going to get into what the mole is. And no, when I talk about the mole, I'm not talking about this little furry shrub rodent that digs and has this weird nose structure on its face that allows for it to smell food underground. I'm talking about this number right here, 6.0, we're seeing 22 times 10 to the 23 molecules. Like I said before, the mole is kind of like me saying something is a dozen. What I'm going to pass out to you guys is I have 4 bars, metal bars. That's what I forgot to do. That was my balance. What we're going to do, I'll pass you. Once you take a look at that and pass them down. So each row is going to have their own bars. We'll move around a little second. But when I say it's a dozen, I'm saying it's a dozen. It doesn't matter which one it is. We see the bars moving around. They both say that they're a mole of something, but they don't specify what the mole is. I'm on.
Oh, okay. Essentially, just all you gotta remember is if it starts off with something.
Could row 2? Could you pass your bars to row 3? Row 1, pass your bars to row 2.
I think that's going to be
All right, I'll help us out here. Where's our bars at from down there? Can you pass up, ladies? Thank you. Bars here. You can see them. Pass them that way. No, so we say that they're both bars. They are both moles, but again, they're clearly different sizes, different materials. Lucia, and I can't remember who's the last person to come in. What you need, come on over here. Kelsey, calculator, periodic table, calculator, and today's worksheet. So take these, pass them on down. Did we get those back? Perfect. All right. Now they are all metals here. Just by looking at your metal bars, which one do you think you can identify just by looking at it? Do you think it's A, B, C, or could you identify what D is just by looking at it?
Yeah.
Which one do you think?
I think it's like copper.
Yeah, well, copper, right? It's got that nice little orangish brown glow to it, right? What about the other ones? They all say mole, but they're all different sizes. Because what we're saying is that 1 mole is going to equal a certain amount of atoms. 6.022 times 10 to the 23 atoms. Now, depending on what that is, will determine whatever that material is going to determine how many atoms is going to be there. So I take my period. Let me see if I just get this thing on. Let's see here, on. All right, perfect. Let me smooth this over for a quick second as I slowly made a mistake and forgot to grab every possible thing that I could have needed today because I am a smart one. I'm going to grab my period, grab my balance here, I'll drop my weight on there. Take a look at your periodic table. And I want you to take a look at the molar mass of copper. Now my balance is quite old and has not been calibrated in quite some time. How close is my molar mass, my weight, to the molar mass of copper? What's on your paper? 63 point what? 0.35? 55. 63.3. That's pretty close. So if I was to take this off, and let's say I was to take a look at A. A gives me a total of 65. If I look at my periodic table, do I see something that's close to 65? Zinc. The mole we're going to see is going to match the molecular mass. The atomic mass. So if A was zinc, D was copper, let's see what B is. B is 27.2. What on the periodic table is closer to 27.2? That's a metal. Was it? Aluminum. Or aluminium if you're from across the pond. Let's see about C. C is 56. iron. The mole of an item will match the atomic mass on the periodic table. Now, like I said on mine, my balance is not calibrated, hasn't been calibrated in quite some time, so it's going to be a little off. Also, I'm only going to only one sig fig. Your answer on your periodic table is more accurate than mine because it has more significant figures. But kind of like how a dozen of something always equals 12, a dozen of an element or of a compound will always equal 6.022 times 10 to the 23 atoms. So I said put this on your whiteboards. I don't have the whiteboards available at the moment, so you can do this on the back of your piece of paper. I want you to practice your dimensional analysis real fast. I'm going to put a timer on the board. Ma'am.
We have problems on the back, but I don't know if you can...
Oh, we have problems on the back. You're probably right. All right.